Hello guys, and welcome back to 5-Star Physics. Today we're going to be focusing on the topic of kinematic equations. So earlier in our last video, we kind of talked about acceleration, new quantity, rate of change of velocity. And so now we're going to be combining that with our other quantities, with velocity and displacement and time, into these equations which we call kinematic equations. The reason for this is because the equations that you previously know, such as delta x equals vt, which is the derivation of v equals delta x over t, these equations talk about averages. And so not every question you're going to be asked is going to ask what is the average velocity, what is the average displacement. It's going to be asked for the specific quantities. So that's what kinematic equations are for. And you can see that for all of them, there's a way to solve for each variable. Like say you're solving for delta x, you could use this one. Say you're solving for VF, you could use this one or this one. Right? The differences between all of these is that each kinematic equation forgets one variable. For example, this first equation here forgets which variable? Well, out of the 5 that we know, delta x, vi, vf, time, and acceleration, the only one that's leaving out is vf. So this one leaves out vf, this one first one. This one, well, leaves out delta x. Third one leaves out time, and so on. And the reason that they all leave out one, and why it's really important, is because when you solve for using a word problem and you have to use these equations, you are not going to get every single variable. You're not going to get all 5 of these. Instead, you're going to get 3, and you have to solve for 4. And that's the interesting thing about these variables, is that you only need 4 of them. Now, there also are some important assumptions that you have to know. And these are the assumptions that we assume whenever we talk about kinematics and physics 1 in general. We assume that acceleration is constant, which means that acceleration is going to be like the same value the entire time. It's not going to be 5 meters per second squared one time, and then all of a sudden after 10 seconds, now it is 10 meters per second squared. That's not how it works. In physics 1, we assume that acceleration is going to stay at its value. Now, don't confuse that and say, okay, velocity is always going to be the same value. That's not true. Only acceleration is going to stay the same value. That's important to know. Another thing that's important to know is that it is one dimension for now. In kinematics, we're only going to be talking about either going horizontally, the x, or vertically, the y, which we'll talk about in the future. But just know that you don't have to worry yet about this, diagonal or going on an angle and, solving for the degree of the angle. Now, before we go into a practice kinematics problem, we need to look at how to actually solve them. And this is going to be really important, and it's important that you use this in every single step you take in kinematics. Your first step always should be draw a picture. Draw a picture of what's happening. If it's saying, a car is moving to the right, a ball is moving to the left, all that kind of stuff, you have to draw it. And the reason for this is in physics, a lot of things are going to be thrown at you, especially in word problems. You're going to get a lot of different objects, a lot of different quantities. And if you don't draw the picture, it's hard to imagine it all in your head. It's hard to visualize all of those quantities in your head. So it's really important to put it down on the page. And then your second step is going to be to organize your knowns and unknowns. And what this basically means is putting your quantities into a chart. So like I talked about before, one quantity is always going to be forgotten. So let's take a look at this. Let's write out all of our quantities. Okay? Now, let's say that in this question, it's not mentioning accelerations. Acceleration is not a thing. So we can cross that out. So that's an unknown. So we're going to put a question mark here, because we don't know it, we don't have to know it. Now, say it gives us a value of delta x, then we have a known. We have, say it gives us vi, say it starts at rest, so vi is 0. And then say it gives us how long this procedure takes. Perfect. So then we know that what we're solving for is our other unknown, which is your vf. And then that is how you would solve. What's really cool about this is that when you start to get into numbers and values for all these different quantities, it's really a cool way to organize all of your information. Say you have a 5-step problem where you have to pull all of these numbers from problems. If you have this chart already here, you just have to look at your chart, put it into your equation, and then easily solve. And then our last step is just going to be using our tools to solve. And what I mean by tools is simply your kinematic equations. So all you're going to do is you're going to take your picture so you know what's going on, you know what equation to use. Then you're going to take your chart and you're going to plug it in, your knowns, into the equation, solve for your unknown, and then that's how you are going to solve your problem. Okay, let's do a practice problem. So while driving to school, Matt was traveling at 20 meters per second when the traffic light 100 meters in front of him turned red. If Matt stops directly at the light, A, what is his acceleration, and B, how long does it take, or in other words, what is his time? So I want you guys to just try this by yourselves, use the step problem-solving process, and then when you're done, come back to the video to see the answer. So now that you've done it, let's take a look. And let's do our problem-solving process. So the first thing that we're going to do is in step 1, which is to draw a picture. So we're going to draw a car here, Matt's car, which is traveling 20 meters per second, right here. And then over here, we have the traffic light. And after traveling, and well, he's 100 meters away, and after traveling this 100 meters, we know that he comes to a stop directly at the light, so this point here, and so his velocity would be 0 meters per second. Okay, perfect. So we drew our picture. I have a visualization of what happened here, so let's do step 2, which is going to be to organize our knowns and unknowns. So, delta x, do we know it? Yes, because the distance that he travels from his origin point here is 100 meters because he comes to a stop here. So, 100 meters. His initial velocity, let's take a look at our picture, 20 meters per second. Our final velocity, we know, is 0 meters per second because he comes abruptly to a stop. And then acceleration, we don't know. That's actually what we're looking for. Time, we also don't know. So 2 unknowns and 3 unknowns. Perfect. It's solvable. So let's think, what equation will we need here? Well, we need an equation that doesn't have time, but does have acceleration because we have no given unit of time and we need to solve for acceleration. And the equation that would be used here would be VF squared equals VI squared plus 2a delta x. And it's important to know that this is the start of step 3. So let's isolate for our variable a. So we do VF squared minus VI squared divided by 2 delta x equals a. What's really important to know is that you should never plug in your number values into your quantities until you've solved algebraically. Because if you do, the numbers can get all mixed up, your algebra could go wrong, and it's really annoying when you mess up your algebra and you could have gotten the right answer. So then let's plug in our values using our chart here. So we know VF is 0, right? So 0 squared minus our initial velocity, which was 20 squared, divided by 2 times our delta x, which was 100, and we're going to get a here. So our a should be equal to 0 minus 400, which is negative 400, divided by 200, it should be negative 2 meters per second squared. Perfect, but we're not done. That was only part A. Now part B, we need to solve for time now. But if we go through our list of knowns and unknowns again, we know delta x, yes, 100 meters. We know VI, yes, 20 meters per second. We know VF, 0. We know acceleration now, negative 2. And we know that we have to solve for time. So now we have 4 known variables. So this is going to be pretty simple. We have our picture, we have everything. So again, we're just going to use our tools to solve. So now let's use the equation. Let's go without acceleration, just to be sure, because you never know. If you messed up your acceleration, let's not risk messing up your time. So we're going to use the equation delta x equals 1/2 VI plus VF times t. and then solve for t, and then plug in your values. So this should be 200, and then this should be 20 plus 0. So 200 divided by 20, and our time should be 10. T equals 10 seconds. If you got that, great. If you didn't, see what you did wrong. Maybe you didn't use a problem-solving process. Just check what you did wrong if you got it wrong, but if you got it right, that's great. So some quick takeaways from this video. I just have two things here. The first thing is the problem-solving process. As we know, draw a picture, organize your knowns and unknowns, and use your tools to solve. This is really important. Now, this will not be the same process as you move on to your next unit, dynamics, as you move on to the unit after that, work, energy, and power, and as you continue in your Physics 1 class. However, it's important to note that the process itself, the name, and the steps are still always going to be a thing. It's going to be a thing for dynamics, it's going to be a thing for energy. You're still going to have to take these steps. Now, the steps are going to differ, but you still need to stay constant to these steps, because I promise you on a quiz or test, say you didn't do as well as you thought you did. Maybe implementing this process, maybe implementing this and using it on your next test, your next quiz, could help you think more clearly about these physics concepts and be able to solve and do better. So it's important that you use it. Trust me, don't ignore it. Now, the second important thing is assumptions. So two really important assumptions I talked about, but that need to be clear, is that acceleration is constant. So you need to know this, is acceleration is constant, because as you will see on the AP exam, on maybe even questions on your test right now, it's going to ask you, what are you assuming? What is the issue? Why is this, not the way that it is? Or, it could ask you a conceptual question. It's important to know what you're assuming and what you're talking about. And that's going to be important for the AP exam. But the second thing is also that for right now, it's one-dimensional. And for this one, for kinematics so far, we've only talked about the x direction. However, in our next video, we're going to be talking about y direction and the concept of what we call free fall. So tune in for that in our next video, and thank you guys for watching.